What is up, Web3 people? I'm Jay, your instructor, and welcome to this Moralis Full Stack course. This course is designed for anyone making their first steps in their development journey, especially in the Web3 world. If you're watching this on the Academy side, I hope you found a lot of valuable content and this course can add to that. But if you're watching this full video on YouTube, I highly recommend you go check out the Moralis Academy, where you can find loads of content just like this, split up into digestible segments with additional learning and quizzes to enforce your learning. But now, without further ado, let's get into this course.
Hey, I'm Jay, your Moralis instructor from beautiful Finland. I got into crypto in 2020, and I've been building in the space ever since. In my free time, I enjoy running and at the gym, and in the summer, you'll definitely find me at the golf course. Now, let's get stuck in and learn about Web3.
Rightio, before we head into the first segment, let's look at the final product of this course. So what you see on the screen right now is going to be the final build. We're going to build a Zapper clone where you can track different tokens depending on which network you select and which wallet address. You'll get the native balance and ERC20 tokens for that wallet. You'll get the ERC20 token transfer history, and then the NFTs that wallet holds, and you can even filter these NFTs based on NFT collection, like so, and the token ID of the NFT. So here you saw a couple of examples. And now how we're going to achieve this is by using the Moralis EVM API. It's a very robust API that lets you query all sorts of data from the blockchain. And to accomplish this, we're going to set up a simple backend server with Node.js. On that backend server, we'll make our API calls to Moralis. And then we're going to create this React Frontend where we're going to call our backend to fetch that data for us. And also on this React Frontend, we'll use the Web3 UI kit to style this page and look very nice. So if you're a bit overwhelmed, it's only because we've added some cool styling, which will be the last segment of this course. At the start, it's only going to look like this, where you can input your wallet details, fetch tokens, transfer histories, and NFTs. So for anyone who is feeling a bit unconfident, I hope this assures you that anyone is able to build this by following this tutorial along. This is just the final product with the nice styling. All right, with this said, let's jump into our code editor and start this project. Alright, so here I'm in my code editor. I use Visual Studio Code, but you can use any other one you prefer. I've opened up a repository called Zapper, so do the same yourself. And in the terminal, I have Zapper open here, so we can start by creating our backend directory, mkdir, make directory, and call it backend. Now this created our backend folder, so we can jump into that by running cd backend. Now the prerequisites for this project are that you have Node.js installed and a package manager like npm. So now we can initialize a Node project by running npm init over here and pressing enter until you're finished. Now, if you check into your backend folder, you have a package.json. And we can also go ahead and create our index.js file by running touch index.js. Perfect. And now for the dependencies we'll use in our backend. Run npm I Moralis express cores.env and nodemon. So those should be all the dependencies we'll be using in our backend. And after you press enter, it'll take a while for them to install, but then we're ready to start building our index.js file. All right, so we patiently waited and our dependencies are now installed. And to go ahead and start with our index.js file, we can use a template. So go over to Google Chrome, type hello world example express, Google search. And the very first one over here should have a sample Node.js Express backend for you to copy out straight away. So just copy that, jump back into Visual Studio Code. You can close your terminal for now, and in your index.js, paste that code like so. Cool. So that's beautiful. First thing we can do is we can change the port our backend will run on to, for example, 8080. We'd like to reserve 3000 for our front end project. And then we'll also bring in the cores package. So this will just make sure that you don't get any restrictions when making your request to this backend. So we'll just have to make sure that our app uses cores. So just over here, add app use cores, and that should have you going. Now you're basically ready to run this very simple hello world Node.js backend. So save that. But in your package.json, you have the scripts. And here, let's add a comma after the test and create a start script. So start, and what will start your backend will be nodemon index.js. So nodemon is a package we installed, like you see over here, and that will just allow us to refresh our backend every time we make changes to our index.js, so we don't have to restart it constantly. So now this is your very first simple backend setup, and the index route over here will just respond with a simple hello world. So we can already give this a whirl. Open up your terminal, And over in the backend, run npm start, the new script we just created. And your example app is listening on port 8080. Now jump into Google Chrome again, and here you can navigate to localhost 8080, like so, and you see we're responded with a hello world if I zoom in, like so. How cool is that? We have our backend set up, and now we just have to make sure that making some request to our backend endpoint, for example, tokens, will give us a response of the tokens of a specific wallet that we provide the arguments for. But before we go ahead and start creating these endpoints, let's connect our backend with our front end. So let's go ahead and create a React app. Jump back into Visual Studio Code. We'll want to leave our backend running, so we go ahead and create a new terminal instance. We see we're in the Zapper folder, so we can go ahead and instantly create a React app over here by running npx create React app, and then give it a name. So we'll call it front end. Press enter, and this should automatically generate a React app into your Zapper folder next to your backend folder. So it's creating it now. Let's wait for a little bit and come back when it's actually created. Perfect. So our front end is ready. We can check it over here. We have the source folder where we have our React app contained within. And over here in our terminal, let's cd into our front end folder. And then by running the command npm start, we're able to launch our React app on localhost 3000. Look at that, compiled successfully, and you can find it on localhost 3000. So jumping back into Google Chrome, we have our backend server over here open, but let's open up our client on localhost 3000, and it should look something like this. So we have a React app. Now this is just a template React app, but now let's do a quick verification that we can actually talk from our backend to our client. So let's start working on this client-side React app. Jump back into Visual Studio Code, close down the files we've already worked on, close down the terminal, and in your front-end folder, locate the app.js file. Over here, what you can do is remove the logo, and you can remove everything inside the div named app, like so. And over here, let's just create a simple button. Let's say fetch hello, and let's add a onClick event to this button. onClick equals, and then create a function, backend call. And now we have to create this function inside our app component. So over here, we create that async function call. It doesn't take any parameters. And now to make that fetch to our backend, we have to install Axios. So over here, open up the terminal. We can close our front end for a while and do npm I Axios. All right, so that's installed now. Close the terminal again and import Axios into our project. Import Axios from Axios. So this will allow us to make a API request to our backend. And doing that is super simple. All we have to do is create a variable called response where we await Axios to get from our backend server, which is located on localhost 8080, and we look at just the index endpoint. So if we look at our backend, index.js, this endpoint will respond with a hello world whenever requested. So now what we can do after we receive the response, we can go ahead and console.log the response. So now when we press our fetch hello button, we launched this backend call function over here where we just await Axios to get from our backend, which is located at localhost 8080, the hello world statement, and then we'll console log it. And it will most likely be stored in the data parameter. So we just push data over there. So now open up your terminal again and run npm start to start your client-side application. Now your React app should update to this page with just fetch hello. We can increase the size over here and open up our console. So right click, inspect, and then press console over here. If we open this up big, now when we press fetch hello, look at this, we get our hello world, which is brought to us from our backend over here. How cool is that? So now you know how you can interact with your front end React app to your NodeJs backend, and we can start making those Moralis API calls in our backend to display them in our React frontend. Let's start doing that now. All right, so the goal for this section is to make a call to the Moralis EVM API to get the native balance of any one wallet, and then display this information in our React app as the native balance for the user we've selected. So to get started, go over to Google and type docs Moralis, make a search, and the first result will be the Moralis documentation. Over at the top, press API reference, and the very first section will be for getting an API key. So to interact with Moralis, you of course have to have a Moralis API key, and this instruction will show you how to get one. Basically, you create an account, go to admin Moralis Web3 APIs, and click to copy the Web3 API key. Now, jump into Visual Studio Code, and you should have your backend folder. In this folder, press the index.js file and create a new file called .env. In this file, create a variable called Moralis _API _key and make it equal to your API key. I'll add mine here, but don't use this and never share your API key. I'm just sharing this one just for demonstration purposes. So always go get your own API key and keep it very, very safe. Beautiful. So now save this file and you can jump back into your index.js file, and by requiring .env and configuring it, you have access to these environment variables in this index.js file. And now we can go ahead and create an endpoint for getting our native balance using Moralis. Let's go over here and copy this hello world endpoint we have on the index endpoint, and over here, get it from native balance. So now localhost 8080/native balance will be the endpoint for getting a native balance for a specified user's wallet address and chain ID. Right, so to get started with this endpoint, every time it's called, let's initialize a instance of Moralis by awaiting Moralis to start and using our API key from our environment variables. But here I notice we haven't actually imported Moralis, so you do that at the top of your file. Go ahead and create a variable called Moralis, which is requiring Moralis default. Default is important here. Now save this, and now we're waiting Moralis to start, but we're actually not making any calls to the EVM API. So go ahead and create a try, and within this try, we'll write our logic, but if we catch an error, we'll respond with the error. Like so, and at the bottom of the try, we'll have our normal response, which is currently just set to hello world string, but after we finish with this try statement, we'll have another response we're sending. Okay, now let's go check out the Moralis documentation. So we're on the get API key page, but over here on the left, we have the EVM API, and looking at the balance column, we have getting native balance, and we have clear instructions on how to handle this get native balance endpoint. The only required parameter it takes is a wallet address, but we can provide a chain ID as well of all the supported chains that Moralis provides, which is basically all the EVM supported chains. Now here in the sample, we see that we can call the EVM API like so. So let's just copy this from over here, jump back into Visual Studio Code, and over here in our try catch statement, let's paste our const response is awaiting Moralis EVM API balance method to get the native balance endpoint. And we have to provide an address and chain. So here, what we have to do is we have to make sure that when calling this native balance endpoint, we pass two parameters, the address and the chain we want to query. And how we can get those passed parameters is by querying the request and then destructuring the address variable and the chain variable. And then we can pass these as the address and the chain for our Moralis EVM API request. And now all this left to do is get the response data, store it in a native balance variable, and then in our response send, pass this native balance object, native balance. So now anytime this native balance endpoint is called with a correct Web3 address and chain, you'll get a response for the native balance on that chain for that wallet. And we can actually test this out because backend should be running here in this other terminal, but it seems like it's crashed. Let's see why. Oh, await is only valid in asynchronous functions. Yes, that's correct. So in your endpoint, you have to provide a async over here because we're using a wait for Moralis to start and we're waiting the Moralis EVM API. So now if you go ahead and save your index.js, your Nodemon will restart your server and it should be running well on port 8080, and we can test that native balance endpoint out. So what we'll do is we'll open up our browser, Google Chrome over here. We have localhost 8080 over here, and then we'll use the native balance endpoint. And then to pass the parameters, you'll have to add a question mark, then pass a address followed by an equal sign and the address you want to add. So we'll add some stars for the moment, and then a add symbol to add the second request parameter, which was the chain, and again an equal sign and the chain we want to add. So now for the address, let's check out my MetaMask. We have the Matic mainnet open over here, and we seem to have 1.3 Matic. And we have this account, so let's copy this account, add it over here to the 3 stars for the address. And then the chain ID for Matic is 0x89. And you can get this from over here. You see Polygon over here is 0x89. And now, if we call this search, look at this, we get a balance of 133, and Matic has 18 decimals, so you have 18 decimal points showed over here, and we have our balance for this user, which corresponds to the same amount we have in our MetaMask wallet for this account. So it's working very well, but only with this balance, we can't do a whole lot. We also have to know what the US dollar value for this balance is. So let's go ahead and next check out how we can use the token price API from Moralis to convert this native balance to the US dollar value. Radio, so checking the Moralis documentation once more, if we check out the token method, we have get token price endpoint. And again, this only requires an address, but this time for a ERC20 token, and then we can also provide the chain that it lives on. Now for the native balances, it'll be either Matic or Ethereum, but we can use the wrapped ERC20 token version to get the token price for these native tokens. And let me show you how we can do this. So jumping back into Visual Studio Code, first, before we send our response back, let's initialize a variable called native currency, because depending on which chain we're on, our native currency will be different. It'll be either Ethereum or Polygon. That's the 2 examples we're using in this build. Close down the terminal if you have it open, just gives you a bit more space. Now what we can do is write a little conditional. We'll check what the chain is from the request. So whether it's Ethereum, so 0x1, we'll use as the native currency the wrapped Ethereum contract from the Ethereum network. So you can check this address, but I'll just point you to the wrapped Ethereum contract on Ethereum. And the same thing over here, if the chain is 0x89, you'll go to the wrapped Matic contract. So this is just wrapped Matic and wrapped Ethereum, so we can get their price using the token price API. So what we'll do now is, because we have the token we're looking for, and we know the chain we're going to query the price for, let's write another Moralis EVM API request. So over here, getting the native price, we await Moralis EVM API using the token method and the get token price endpoint. For the address, we're using the native currency. We set just here in our conditional. Here we have a comment. So if we're on the Ethereum network, this points to the wrapped Ethereum contract. And for the chain, we're using the chain we're getting from our request to this endpoint. And now with the native price, we can set this as another key to our native balance object over here. So let's do that over here. Native balance USD will equal our native price that we're just awaited over here. We'll get the data and we'll get the USD price key. Now, in our response, we'll not only have the balance of the user, but the current price for that native token. So if we save this, if you check out your terminal, your NodeJs should have restarted your server, so you can run in Google Chrome on your local host 8080 native balance request, rerun this, so refresh, and look at that. Now we get the USD price for Polygon, which is currently at 74 cents. How cool is that? So now you know the balance of the user you queried and the actual price for that one token is going for. So in your client side, you can deduct the dollar value of this user's balance. So now that is it for our first endpoint, and we can jump in to presenting this in our React app. Perfect. So you can jump back into Visual Studio Code, and for the time being, you can close the index.js and env file and the backend folder and open up the frontend.js folder, open up source and app.js. In here now, we want to create a user interface where the user can set a wallet address and the chain they want to query, and as a response, display the native balance of that user they queried. Now what this means is we can get rid of our testing functionality over here, getting the hello world and this button away, And instead of Axios in this app.js file, let's import useState, which will handle our state variables like so. So now we have state, and we can create those state variables for the chain and the wallet address. Over here, we set a wallet variable, and then the set wallet hook sets this wallet variable. We initialize it to an empty string, and the same thing for the chain. We initialize it to the Ethereum network, and the set chain hook can set this chain variable. And now let's create a component in which we can set these two variables for our whole app. So inside our app div, create a component called wallet inputs, and as props, it takes the chain, set chain, wallet, and setting wallet. So now what we have to do is create this wallet inputs component. So we can do it in this source folder. Let's create a new folder, call it components. And in here, create a new file called wallet inputs.js. And as we open it, if you type in RFCE, you should be able to create a React functional component with the name of the file. So wallet inputs over here. Currently it's just returning a div called wallet inputs, but we'll make the modifications here shortly. What you'll have to pass over here are the props we set in our app.js. So the chain, set chain, wallet, and set wallet. So this child component can use those parent component state variables. So like so, we paste them in there, and now we can jump in to the return argument. So what is this component going to return? First, let's wrap it around empty tags, so React will like it. And starting off, we can add, for example, a heading, input a wallet and chain. Then next, we'll add a paragraph like so, where we have a title called set wallet, and then we have a input tag, which on chains sets the wallet state variable to the target value of this text input field. Now, after that, we only have to set the chain, and because we only have two options, we'll use a select input for setting the chain. So again, over here, because we have a paragraph, this will be on the next line, setting the chain, and it'll be a select input, while on change, it will set the change to whatever option is selected, and we have two options. The first has the value for ETH, which is 0x1, and the second has the value for Polygon, which is 0x89, which we need for our backend request, as you remembered. So now we can have a wallet address and a chain ID we can set from our front end when calling our backend. If you press Option Shift F, you should be able to style this page nicely and indent it properly. Then press save, and in your app.js file, just be sure to import this newly created component, wallet inputs like so, from component/wallet inputs. Save that, and now checking your React front end, you should be able to input a wallet and chain, set wallet, and set the chain between ETH and Polygon. How cool is that? So now, when we have our inputs, we can create another component which has a button to request data from our backend for the native balance of a wallet and chain we set over here. So let's do that next. Jump back into Visual Studio Code. In here now, for our native value and native balance, we can create two other state variables, native balance and native value, and setting them with these two hooks. And now let's create that component underneath our wallet inputs component like so. So again, we pass the same props, wallet and chain. We don't need to set the wallet and chain in this component. We just need to get the value of the wallet and chain for our Axios request. And then we set our native balance, and we need to be able to set our native balance and set our native value in this component. So now jumping back into our components folder, click wallet inputs and create a new file, native tokens.js. Make sure you type it right. And then again, by running RFCE, you can create a React functional component with the name of the file. At the start over here, let's import Axios because we're going to be making that request to our backend. Boom shakalaka. And then for the props that we set in our parent component, add those in here like so. So we have a wallet, chain, native balance, setting of the native balance, native value, and setting of the native value. Let's close out the file structure here so we have a bit more space. And here, before we start working with the HTML we're going to return, let's write that function to call our backend. What we'll call it is getNativeBalance. And again, we'll do a Axios request like we did in the initial example, hello world. So we create this variable called response. We await Axios to get from our backend, localhost 8080, the native balance endpoint, but this time we pass the parameters in this object over here. So we set parameters, and as the address, we set the wallet the user sets in the wallet inputs over here. And the same thing for this chain, we set the chain the user can set in the wallet inputs. And now with that response, we have to check whether that response has a balance and USD price. And if it does, we can set those to the native balance and the native value. So here is our conditional. If the response data has a balance and the response data has a USD key. So if we check out Google Chrome over here, so as long as we have a balance and USD, we know that our request to our backend had succeeded. And then we can set the balance using our set native balance hook. And we make sure we convert the response data balance to a number, and then we divide by 10 to the power of 18, which is the decimals for most native currencies, Ethereum and Polygon. And then we round it to a fixed 3 decimal points, just so that we don't have that long string. So it's just a bit more human readable. And now for the same thing, for setting that USD value, over here, we use the set native value hook. And this time we again get the balance and divide it by 10 to the power of 18, which is the decimals. But then we multiply this by the USD price for one token, and this will give us the USD value of this user's balance. And then for this, we put it to 2 decimal points because we're not going to be looking at values less than 1 cent. Now, all we have to do is, using the native balance state variable and native value state value, set our return statement to display the user's native balance and USD value. So again, make those empty tags over here, in which we can put our HTML. First, we'll put a title fetching the tokens, and then let me just paste the whole rest of the HTML. And now let's talk through it. So here we have a button which on click runs the get native balance function we just created over here. So it makes that request to our backend to get the user's native balance. And then we have a span tag over here that says native balance. And the first thing it presents is the native balance. And then the next thing is a $sign with the native value of the user. And we can go check this out right now. So we save this. And before we jump back into our React app, go to your app.js file and make sure you import the component, import native tokens from components/native tokens, save that. And now your React app should be up to date. Jump back into Google Chrome and look at this. We have our native balance is set to $0 and $0 out right now. But now if we set the wallet address, jump back into our MetaMask, grab our wallet address from there, paste it in here, set the chain to Polygon, and fetch our balance. Look at this. It says our balance is 1.332 Polygon. And wouldn't you look at that? That translates to $1 at the current conversion rate. So that is the first step of creating a Moralis API request in your backend and initiating that backend endpoint from your React frontend to display that data in your React frontend. You've come a long way, and now next thing is to do this exact same thing with ERC20 tokens. Hope you're excited for that. Let's jump into it. All right. So this segment is all about getting the user's ERC20 balance on the chain you've selected. So in the last section, we created this endpoint called native balance, and that uses Moralis balance method to get the native balance of the user, depending on the parameters set in the request, the address of the wallet, and the chain ID. But now, essentially, we want to do the exact same thing, but for ERC20 tokens. So we can use this as a template. So go ahead and copy this endpoint like so, Command C, and then below this endpoint, create a new endpoint, which we will call not native balance, but in this case, this will be called token balances. We can go ahead and remove everything from the declaration of the native balance variable, like so. And over here, you see that we're trying to get from the Moralis EVM API, the balance method. But this time, we're not going to use the balance method. And I encourage you to go check out the documentation yourself this time. I won't show it because it's great for you to get into the practice of learning to read the documentation and finding the endpoints you're going to use. So here we're going to use, from the token method, getting the wallet token balances. And ideally for us, it takes the same parameters, the wallet address and the chain we want to check out. And now all we have to do is declare a variable called tokens, let tokens equal, and from our response, from the Moralis EVM API, we get the data, and then we can respond with that as long as we don't catch an error. So we respond with the token. Let's actually call it tokens, not tokens, like so. So now this is all you have to do to get the token balances of a user. It's very simple because we can reuse the code from the previous endpoint over here. So don't get too excited yet because we'll add some filtering, but now we can go check this out because as we press save, now NodeJs should have updated our server. Look at this. The server was restarted, so we can close this now and jump into Google Chrome and make a request to our backend and see the token balances of a user. Okay, so opening up Google Chrome, you should have this window open still. We used it in the previous segment where we made a GET request to our backend localhost 88 to the native balance endpoint using the address parameter and the chain parameter over here. So all we have to do here is change the endpoint from native balance to token balances, like so, and as we press enter, now we get another response from our backend. Look at this. We get two tokens, the token address over here, the name USD coin, and the other coin is wrapped ether. And we also get the balance of that token with the decimals that that token has on the network. How cool is that? We now have the token balance for this user. But what I want to do is I want to get the price of these tokens as well and filter out the tokens where the price is less than 0.01, as these are most likely so-called scam tokens. So to do this better, let me use a different address over here. Right, so I know that this wallet address on the Ethereum network, so changing the network from Polygon to Ethereum, holds two tokens, USDC coins, which are $1 worth, and some of these essentially zero value tokens called poodle tokens. So let's search this and look at this. We get two tokens. We get a token address first for this poodle token, where the balance is absolutely astronomical, but the price of these poodle tokens is minuscule. But then we have US dollar coins. We have $6 worth of US dollar coins. So what we want to do is make sure that we know the price of these poodle coins and filter them out because we don't want to show them. We just want to show the US dollar coins. Hope that makes sense. So now let's jump into Visual Studio Code and make that happen. Right, so back here in Visual Studio Code, after we get our tokens, let's initialize an array called legit tokens equals an empty array. Now let's write a for loop where we loop around all these tokens we got from our initial response, like so. Let's scroll down a little bit. So we're starting the loop from 0 and we're looping around the token's length. So in this case, we'll have two tokens, USD coins and the poodle tokens. Now what we're going to do in this loop is we're going to use the token price API we already used in our native balance over here, get the token price, to get the price of these ERC tokens this wallet holds. So over here, we're going to await the Moralis EVM API token method to get token price for our token address from our initial response, and we're going to call that price response. Now we can check if the price response USD price is over 0.01, so 1 penny. We can take the index from the tokens array we're currently looking at, add a USD key, and put the price into that key. So now our initial response will also have the USD price for that token. And then we can push this token into the legit tokens array we created, which will then have as the response. But otherwise, if the price isn't over $0.01, we can just console log in our terminal for our backend, like so, coin. So that kind of gives us an indication that we know that some of the tokens have not fit the criteria of being a price of above $0.01. Go ahead and scroll down and just make sure that your response you're sending to whoever's making a call to this endpoint is the legit tokens array, like so. Save this. And for this, let's open up our terminal. So now we see our terminal and go back into Google Chrome and let's go ahead and rerun this request. And look at this, we now only get the USD coin, and when we check out Visual Studio Code, we have one poop coin over here because once the poodle coin went through the get token price endpoint and this conditional statement, it was caught by not being over the price of 1 penny, and thus our backend console logged a poop coin so we don't present it, and the endpoint only responds with the legit tokens, so USDC coin in this case. So that is the endpoint for getting token balances for a user for a specified wallet and chain. So now what's left to do is go ahead and add these ERC20 tokens to our React client, let's do that next. Opening up Visual Studio Code, closing out our backend index.js, and opening up the front end and going into the source folder app.js. Let's start working in here. All right, so for our whole app, let's initialize a variable, a state variable called tokens, which is an empty array at the start, and a set tokens hook, which we can use to set this tokens array to whatever we get as a response from our backend. And then again, like we did previously, but by creating this component for wallet inputs and native tokens, let's create a component for tokens like so. So our tokens, because we're making a call to the endpoint, we need to know the wallet and chain we want to query the ERC tokens for. And then we also need to get the tokens, as in the tokens component, we're going to display the token information, and we're also going to be setting the tokens in this component. So we need to pass all these as props to the tokens. And then we can go ahead and jump into the components folder, create a new file called tokens.js. And in here, create that React functional component by running rfce. And then it creates us our component with the same name as the file name. All right, so first of all, let's import Axios, as we'll need it to make a request to our backend. And then for the props that we defined in our parent component, let's bring them into this child component as well. Wallet, chain, tokens, and set tokens. And then let's create our function to make a call to our backend. Okay, so get token balances is the asynchronous function we're calling it. And then let's go ahead and make that request to localhost 8080 like so. So we get the response variable by awaiting Axios to get from localhost 8080 our token balances endpoint we just created. And as the parameters, we're passing the address and the chain we have from our parent component, which we're setting in the wallet inputs created in the earlier segments of this tutorial. So now jumping back into the tokens component, let's go ahead and check if we get a response and it has data within it. And then if it does, let's call it t. So response data equals t. And if you remember, in our native tokens component, if we had a response data, we set the native balance and the native value like so, where we had to do some computation using the balance and the decimals and the USD price to get the actual human readable forms of the data. So we'll have to do the same in here, but because we're working with an array this time, we'll have to loop around the whole array t over here. All right, so go ahead and create this loop where we loop around the length of t. So just make sure you're following. Let's open up a Google Chrome and make sure that you know what's going on. This is the response we're getting. In this case, this wallet only has one token, so the length of this for loop would just be that one iteration. But if we change to the original wallet we were working with over here, change this wallet over here, and look at the Matic network, this response gives us two tokens. So we have the USD coins and the wrapped Ethereum. So we'll have to wrap through two of these and use the balance and decimals to get the human readable form of the balance, and then use the USD price to get the dollar value of the holdings of that ERC20 token. Hopefully this makes sense, but now let's go ahead and do that in Visual Studio Code. All right, so first in our first iteration of the T array, let's add a balance key where we take the balance of that user's ERC20 tokens, we divide by the decimals. So we're using 1E18 over here. We're just formatting it nicely. We're getting the decimals from the initial response and we're dividing it, and then we're displaying the balance to 3 decimal points. And then we can do the exact same thing but for the USD price, and this key we'll call BAL, and we're doing the same thing. We're dividing the balance by the decimals and multiplying by the USD price and giving it to 2 decimal points. And now all that's left to do is setting the app's tokens state variable to this T array that we've just created over in here, and that should allow us to display the tokens in our React app. I know this might be a lot, but take your time, rewatch this segment if you need to, and also use the forum to ask questions if something was left unclear. Save that now, scroll to the bottom of the component where we have our return statement, and let's return a nice component with details of all the tokens this user holds. So start off with empty tags, then create a paragraph like so. Let's kick this off with a button that allows us to call this get token balances function like so. So we're calling get tokens and it's on click running the get token balances function. And then let's add a break. So go on the next line, and then we'll just do a little bit of conditional rendering like so. So we're looking at the whole app's token state variable, and we're checking that it has a length of over 0, so it's not an empty array. So this means that we've already called our getTokenBalances function and our backend, and we've got some tokens, and then we'll map through each of these tokens, and we'll just display the symbol of the token, the val we just calculated up here, right, like so, and the value in USD form right here. And that is all you have to do. Save that, jump into your app.js file, and now because your tokens component is ready, you can import it at the top of the file. Import tokens from the components folder and the tokens script. Save that. And just to make our page look a bit nicer, you can jump into app.css. Here, most of this data is unnecessary anyway, so you can delete all of it except the app class. And rather than having text align center, let's go text align left, just to align all our content on the left side of the page. Save that, and now you should be able to go check out your cool React app with the possibility to fetch tokens, not only for your native balance, but for your ERC20 tokens as well. So let's input our wallet in here, like so. We're on the Polygon network, fetch our balance. That's 1332 Matic, seems about correct. 1332 Matic, let's check our assets. So we have 1.7 USDC and 0.005 WETH, and let's fetch our tokens. Look at that. 1.758 USDC, and WETH, because we're using three decimals, we're rounding to 0.01 wrapped Ethereum. So everything is working beautifully so far. Congratulations for making this far. Now in the next segment, let's look at how we can make a component which combines the native balance and the ERC20 token balances and gives us a total portfolio value. So essentially we won't need to make a backend endpoint because we already have all the data on our React client. We just have to make a new component called portfolio value, which combines all of this data into one simple figure for the user to view their whole portfolio value. Rightio, so there's going to be a short little segment on how to combine all the data we have so far, so the native token values and all the ERC20 token values, into one single component with the full portfolio value. We won't even have to set a app-wide state variable because this will only be displayed in the portfolio value component. So let's go ahead and create that portfolio value component over here. Portfolio value, and as props it'll take the native value and the tokens array, so we can loop through the tokens array and check the value of each token. Now with this component created, let's jump into the components folder, create a new file called portfoliovalue.js. Again, in the file rfce, we'll create you a React functional component with the name of the file. Now, this component won't need Axios, but we will need useState and useEffect to store the state variable of the portfolio value, and whenever the native value or tokens change, we can update the state of the portfolio value. So create that state variable for this component of how much the portfolio value is, like so. So the total value, and setting the total value initially to 0. Then we'll create a useEffect. So useEffect is something that is triggered every time something in the input array changes. So we'll define an array here, and we'll put the native value and the tokens within here. But of course, we have to pass them as props to this child component as we define them in the parent component. So now every time this native value or tokens change from our parent component, we can run anything in this useEffect hook. And what we're going to run is setting of the total value of this portfolio. All right, so initially let's set a variable called val to 0. Then let's go ahead and create a for loop that loops around all our tokens. And every single token has a key called BAL, which has a US dollar price value for the holdings of that ERC20 token. So we can add those to the value variable, like so. So we take our value, we add whatever it's in the value to the value of each token. And now what's left to do is add the native token value to this temporary variable. So just make sure you do this outside the loop, otherwise you'll be adding the native value as many times as you have tokens in your wallet. All that's left to do is now setting of this total value state variable for this portfolio value component. So we take our temporary val variable and we set it to 2 decimal points. So we get the total value in US dollars for all the ERC20 tokens and the native balance, whether it's Ethereum or Matic. It's as simple as that. All we have to do is return a component that has the total value presented within it. So in the return statement, again, 2 empty tag. And then in here, let's go ahead and, for example, give a portfolio total value heading, and then create a paragraph in which we have a span saying the total balance, and it's the total value state variable that we have set for this component. And that is all there is to it. Save that, jump into app.js. And now we've created the portfolio component, so we can import it at the top of the file. Import portfolio value like so, save that, and now you should be ready to rock. Jumping into your React app, look at this, total balance 341. So that's all of these combined, 0.96, 1.76, and 0.69 will equal $3.41. Now, if you refresh the page, see the total balance is set to 0. Let's try a different wallet. So this is the wallet we showed in a previous segment where we did some filtering. So this should have some native balance on the Ethereum network. So we have $6.55 of Ethereum. And then if we get the tokens, notice we just get the $6 of USDC coins and we don't display the poodle tokens. So we get a total balance of $13 over here, which is the combination of our native balance and our token balance. So everything is working beautifully. That's how you get the total portfolio value for a designated wallet address on a designated chain. In the next segment, we'll take a look at how we can look at the transfers of ERC20 tokens this wallet has been a part of, so inflows and outflows of ERC20 tokens. Let's get into that next. Rightio, so this segment is all about getting the user's ERC20 token transfers. Moralis provides a lot of different endpoints, so you could also get NFT transfers, native token transfers, but that's a little challenge for yourself to dig through the documentation and see what token transfers you want to add into your app. But in this course, we'll use the ERC20 token transfers. So if you're not already, jump into the backend folder and the index.js file, and we'll create a new endpoint. So we have the native balance endpoint already, and we have the token balances endpoint. We can use the token balances as a template for this endpoint as well. So just go ahead and copy that, and below this endpoint, paste it in. What we're gonna do is we're gonna call it token transfers, like so. And let's go ahead and remove everything below the response variable over here, like so. So before we say this, we'll set the response that we're gonna send to something different. But at the current moment, we're looking at the token method and get wallet token balances. But there's another endpoint in this token method called get wallet token transfers is what we're going to use for this. And ideally, because Moralis is made so cool, it uses the same endpoints. We define the address we want to check the transfers for and the chain we're going to look on. All right, so now working with our response, the data in the response will have a results array within it, which has details of each transaction. So that's why we'll create a variable called user trans and call it response data results. Now we can respond to any endpoint call to this token transfers endpoint with the user trans. And if we save that, our NodeJs should have updated our server like it did. Perfect. And we can go check this out by doing a request to localhost 8080 token transfers for a specified address and chain and see how we can further modify our endpoint functionality to give us more accurate data in the form that we could use it in our React app. So opening up Google Chrome, and here we have the address bar where we're sending a get request to localhost 8080 token balances, but this time let's send the request to token transfers. Press enter to launch the get request, and instantly we get a response of all these transactions of ERC20 tokens this wallet on the Polygon chain has been part of. And so in this case, we seem to have 8 transactions, and each transaction seems to have an address, which dignifies the token that was transferred. We have a block timestamp, so when the transfer happened. We also have a to address, so who the transaction was sent to, and then a from address, so who the transaction was sent from, and finally a value, so the amount of tokens that was sent within this transaction. You notice that we do not get the token price or the decimals, so it's going to be very hard for a human to read how many tokens and what value was sent. So we'll have to make another API request to Moralis to figure out each tokens based on the token address over here, get the token details, so the decimals, so we can present them in our React app in a user-friendly way. So let's get into that next. Jump back into Visual Studio Code. And here under the user trans variable, let's create a temporary variable, user trans with the details, which is an empty array, where we'll push every index from the user transaction variable, but make an EVM API request, Moralis token metadata endpoint, to add token metadata details to every user transaction so we can easily convert them to be easily readable by the user. So as foreshadowed there, let's create a for loop where we loop through every user transaction in this original variable over here. and start off by creating a meta response variable where we await the Moralis EVM API using the token method again, but this time using the get token metadata endpoint, which can take an array of token addresses to get the metadata for it. But in our case, we'll only have that one token in each transaction. We're getting the address from the initial response, and then we're using the chain we're getting from the original request. Then if we scroll down a little bit, we can write a conditional. If we get a metadata response from this get token metadata endpoint, we create two keys in our original user transactions. We create a decimals key and a symbol key. And then from our metadata response, we take the first object because it returns an array, because we're requesting an array, it returns an array, and we'll get the decimals and symbol from the metadata response and push them into this temporary user transaction details array so that we have all the user transactions, but now in addition that we have the decimals info and the symbol of the token as the information. And if Moralis EVM API isn't able to get metadata for the token we're requesting, we can just console log no details for that coin in our backend server. This shouldn't be the case because Moralis was very capable of getting the metadata details for any coin you could think of. Now, finally, we're not responding with the user transactions anymore. We're responding with the user transaction with the details variable like so. And that is all you have to do. Save that, check that your server restarted. If it did, perfect. Then jump back into Google Chrome and we can make this request again. So refresh this page and look at that. Each transaction is now followed by a decimal key and a symbol key. So in this case, we had 6 decimals for USDC. And in this prior transaction, we have 18 decimals because we transferred wrapped Ethereum. So now this is all very good and dandy. We have all the transactions, and in the transactions objects, we have all the details we need to present to the user so they can clearly follow what transactions have happened in this wallet. Let's go ahead and build this out in our React app now. Okay, opening up Visual Studio Code, we can close down our backend files again and open up our front end, source folder, and app.js. For the state variables for the whole app, we'll now have to create a variable called transfers and then the hook to set these transfers, and we'll initially set it to an empty array. Now, then again, we'll create a component under our portfolio value component, which we can call, for example, transfer history. And this will, as props, takes the chain and wallet, again, because we have to make that backend call in this component. And then we'll have to present the transfers. So I'll have to have the transfers state variable, and I'll have to be able to set the transfers after it gets the response from the backend call. So we'll have to have the set transfers hook in here as well. Now with that ready, jump into the components folder, create a new file, call it transfer history.js, and go ahead and create a React functional component, RFCE. And we have a transfer history component over here, which we can start off by importing Axios. Like so, that's Axios imported. And then again, we need to add the props as we did in the parent component. In the child component, we'll have the chain, wallet, transfers, and set transfers. Now it's going to be a simple function to get our token transfers, as we've done in previous components as well. We'll make an asynchronous function called get token transfers, as we'll have to wait for Axios to get our token transfers from our backend. And we do it as follows. We set a variable called response. We await Axios to get from localhost 8080 our token transfers endpoint. And as parameters, we pass the wallet and chain that's being set in our front end. And then we have that response object, which we can check if it has data within it, like so. If response has data, then we are able to set our transfers state variable to that response data. So now we have a big array of all the transactions the user has been part of, and we can use that data to present a table of all the transactions with the from address, to address, the token, its symbol, the value, and the date it was transferred. How cool does that sound? That's all you have to do on the function side, and now we can go to returning that component. Again, add some empty tags over here to make React happy, like so, and we'll write our component inside here. So starting off, we'll have a transfer history title, h1, and then we'll have a div where we'll place our table within. So we'll create a table over here, but before our table, we'll have to have the button in which an on-click event fires the get token transfers function over here to fetch our token transfers and store them in the transfers state variable. So now creating that table like so. Scroll down a little bit. So we have a table where our first table row has 5 table headings. So the token that's being transferred, the amount, the from address, the to address, and the date. Now underneath this token row, we'll have to map through our transfers array. So transfers array, we're already bringing in as props to this component. We'll have to check conditionally whether the transfers length is over 0. So whether we've already made the call to our backend to get the transfers. If we have, then we'll have an array of transfers and we can map through it. And what we'll return for every transfer is a new table row where the cells in the table, the first one will be the symbol of the token, the next one will be the value. So we're using the value and we're dividing by the decimals, and we got these decimals because we made that second call to the Moralis EVM API to get the token metadata. That's why we had to do that. And then we have the from address, the to address, and the block timestamp. So we have all this information about every single transfer in a nice, neat little table for us. You can save this, jump back into app.js, and because now we've created the transfer history component, we can import it into our app, import transfer history from our components folder and transfer history file, save that, and you should be ready to rock. Jump into your React app, Google Chrome, React app over here. You see that our table is set over here because that's not conditionally rendered. Only the contents is conditionally rendered. And because we don't have a user yet and we haven't pressed the fetch transfers button, we don't have any data for transfers. Now let's set our wallet again over here, go to the Polygon network and fetch our transfers. This should give us 8 transfers. Look at that. How cool is that? We have our tokens. So we've got USDC tokens. Mostly all the transactions are USDC, but then we have this one transfer of wrapped Ethereum. They're all from the same address and they're all coming in to our own address. And then we also have the dates when these have happened. You can even check by getting your token balances over here. You see that we have 1.758 US dollar coins and 0.001 wrapped Ethereum. That matches what our table is saying. We have one inflow of 0.001 wrapped Ethereum and all these other inflows of US dollar coins, which totals to the 1.758 US dollar coins in this wallet. Again, you're doing great so far. This was fetching ERC20 tokens. Like I said, there's also other sorts of other endpoints in the Moralis EVM API. You can get native transfers, you can get transactions, you can get NFT transfers, all sorts. You go check it out yourself. That's the way you learn. But this was an example of how you can accomplish this. Finally, the final functionality of the Moralis EVM API I'm going to show is getting a portfolio's NFT collection. And then from there, the final chapter will be styling this and making it look all pretty in a form where you'd be proud to show it off to your friends. Okay, let's jump into the next section, creating an NFT portfolio. Okay. So this segment is all about getting a user's NFT portfolio for a specific chain. So how we're going to accomplish this is very similar to all our other endpoints. We have the native balance endpoint so far, the token balances endpoint, and the token transfers endpoint. And again, we can use one of these as a template for our NFT portfolio endpoint. So copy this over here and Control C and chuck a new endpoint at the bottom, which we will call not token transfers, but NFT balance. Again, you can go ahead and remove everything below the response variable over here. And for this endpoint, because the Moralis NFT API is industry leading by far, you'll get all the details you need for a portfolio component by just one simple call using the NFT method. So here in our Moralis EVM API call, we'll remove the token method and we'll add the NFT method where we're going to get the wallet NFTs, like so. That's all it is. And again, because everything is so uniform with Moralis, all you need to provide as parameters are the address of the user and the chain you want the NFTs for. These are of course passed in our front end call as parameters. So now all you have to do is respond to the user with the response.data and you'll have everything you need about the NFT portfolio of the given address on a given chain. That's how simple it is. And we'll do more work on the client side of displaying this information nicely. So let's go ahead and save this and jump in to Google Chrome where we're calling the localhost 8080 in a simple GET request over here in the navbar. And rather than calling the token transfers endpoint, let's now call the NFT balance endpoint. Press enter and look at this. We get a big object with a total of 4 NFTs and the result array over here has all the tokens we have in this wallet. When viewing this response on our browser, it might be a bit unclear on what the data is giving us, this results array. So let's go ahead and jump into the Moralis documentation, check out the NFT API, and get wallet NFTs over here. Then if we scroll down, we can go ahead and check out the response. So what this gives, again, you saw the total amount of NFTs, but then we have this results array, which has an object for each NFT we hold. Every NFT will have the NFT contract address that the NFT is a part of, the token ID, and here at the bottom, there'll also be metadata for that NFT. And within this metadata, let's jump back over here. You see, for example, the metadata is here. We'll have different things like the ID, the name, the description of the NFT. And for us, most importantly, if you do a command find and search for image, there'll be an image directing you to a URL where the image for that NFT is stored. And you see we have 4 of these images pop up because there's 4 NFTs and all their image assets are shown over here. So when we're working on our front end, you'll know that we're looking at the metadata object, parsing it, and we're getting the image attributes where we can find the image for each NFT and display them in our UI in a friendly way. So that's a little bit about the response for the NFT endpoint. Now let's jump back into our React app and display all this information neatly. Let's go ahead and open Visual Studio Code, and we can close our backend files and jump into our front-end folder, source folder, and app.js. Here, now let's create a state variable for the whole app, which will have an array of all our NFTs. So for good naming conventions, we'll just call it NFTs, and we'll have the set NFTs hook, which will set this state variable. Now again, we'll create a component where we'll make the backend API request to get our NFTs for our wallet and then display them. So exactly similarly to the transfer history, we need a chain and wallet to make the API request, and then we need to have the NFTs state variable to be able to display them, and set NFTs hook to be able to set the NFTs after we make that API request. Now jump into the components folder and create a new file. Let's call it nfts.js, and here create a React functional component. You should be very familiar with this right now because we've done this a couple of times in this course already. And now again, start off by importing Axios like so, and then bringing in our props over here into the component. Set NFTs, wallet, and chain. Now, starting off, we'll of course have to make our function that calls our backend to get our NFTs for the wallet and chain that's selected on the front end. It is going to be an asynchronous function called getUserNFTs, as we have to wait for the response from our backend, like so. Again, localhost 8080 and NFT balance parameters are the wallet and chain set in the front end. Now, let's go ahead and check if the response has data and the results array within it, like so, if response data results. And then we'll call another function called NFT processing, where we'll pass the result array as an argument to this function. So now let's go ahead and create this NFT processing function. And the idea of this NFT processing function is to look into that metadata object and fetch the image for us so we can display it in our front end. So again, function NFT processing, and it'll take an argument called T, for example. For some reason, it's not recognizing this function. That's because the P is in a capital. So now it's colored. And now we can loop around all our NFTs we get from our response. So it's passed as an argument to the NFT processing function over here. So it's just going to be indicated with a T. So we can create that for loop over here. Starting from 0, we're going to loop through the length of NFTs this wallet holds. Now in this loop, what we're going to do first is we're going to parse the metadata for that NFT. So now we have a nice object of the metadata, and then we have to make sure that there is that metadata object, and within that metadata object, there is an image key. If there's an image key, we also have to check whether it has a dot, because sometimes only the IPFS content identifier is included. So then we have to add an IPFS URL to be able to fetch that image. So, okay, so I blubbered along a lot, but let's look at this. So if the metadata image includes a dot within the URL, it most likely is a URL, and we can set a image key for our NFT, which has the image from the metadata object. So now the object containing the NFT data also has a key called image, and it's not only stored in the metadata. The same thing we can do here. If it doesn't have a dot, then we'll still make that image key in our NFT object, but we'll add a URL to IPFS and then only have the IPFS content identifier, which is stored in the metadata, added to this string. So this is just a way where some NFT collections reduce the size of their metadata by inputting only the content identifier for IPFS in the metadata, and then you have to provide a IPFS URL to be able to view that NFT that's stored on IPFS. But sometimes if it's stored on centralized storage or whatever, you might have the whole NFT image URL, which you can get directly. And that is the whole for loop for getting images for each of our NFTs. So now we can just set our global state variable for NFTs to the T variable over here, like so. Set NFTs as T. So now our app has this NFTs variable, which we can use to display the token ID and image of all the NFTs the wallet holds. So let's jump into the return statement over here. Remove what we have currently, add some empty tags and a heading with a div as well, where we'll actually map through our NFTs array and display the images for the NFTs. So here we'll make that map like so. It's super simple. We're again checking that our NFTs array is greater than 0. And this reminds me, we won't have an NFTs array if we haven't run our get user NFTs function. So we have to create a button over here that gets our users NFTs, but that's just super simple over here. We create a button, on click, we run the get user NFTs, and it says fetch NFTs. And now looking at the map, if we've got some user NFTs, so the length of the NFTs array is greater than 0, we can map through them, and we can check if a image key now exists in the NFT object. We display that image, we give it a width of 200, and otherwise we'll just display the name and the token ID of the NFT, which is stored in the object by default. So that is all we have to do. Save that, jump into app.js. We've created this NFTs component, so we can import it. Import NFTs like so from components NFTs, save that. And once again, you can jump into Google Chrome, check out your React app and look at this. Your portfolio NFTs are here. Set the wallet. So make sure you select a wallet which has some NFTs. We'll check this wallet on the Polygon network, fetch these NFTs, and in no time at all, the NFTs popped up. We didn't add a break, so the button is kind of weirdly over here, but we have all these NFTs. We have 4 NFTs. We have the name and the ID of each NFT. How cool is that? Let's just go ahead and add that break over here so it doesn't look so weird. So jump into the NFTs component, and underneath the button, add a break like so. Save that. Jumping into the app, now your button is over here. But look at this, we have all our NFTs for our wallet. We even have the name and the ID of each NFT. How cool is that? So the final thing before we head into the styling chapter, we'll create some filters over here. So if you have a large selection of NFTs, you can filter by the name of the NFT or the token ID, so you don't have to display them all at once. Let's get into that next. Rightio. So in the last section, we looked at how setting a wallet and a chain, you can get the NFT portfolio for that wallet on that chain very easily using the Moralis Get Wallet NFT API. But now say you had a load of NFTs. Here we have 2 NFTs from the Rev Motorsport collection and 2 Lens NFTs. You wanted to filter these out. You don't want to show all of them or find a specific NFT. In this section, we're going to look at how you can create input fields where you can input a name or a ID. And on the client side, it'll filter out all the NFTs that don't match the criteria you set in your filters. Let's delve into that by jumping into Visual Studio Code. In your frontend folder, you should be in your app.js file and creating a state variable for the app called filtered NFTs. So in the last section, we created the state variable NFTs, which will be an array of all the NFTs with all the details of the NFTs. But this filtered NFTs will be exactly the same, except it'll always update when you update your input fields to only include the NFTs which match the filter conditions. So this filtered NFTs, you'll also have to pass as props for your NFTs component. So add them over here like so. So the state variable itself and the hook for setting the filtered NFTs. Now saving that, you can jump into your components folder and the NFTs component, which we already worked on. And over here, make sure you pass the props that we already set in the parent component in the child component itself as well. So we have filtered NFTs and setting of the filtered NFTs as props for this NFT component as well. And now we're ready to start building out this component with the filters in it. First thing we have to do is import useState and useEffect from React to this component, because we'll have to keep track of the name filter and the ID filter in a state variable, and we'll add a useEffect to check whenever the filters change, and in that case change the filtered NFTs for the whole app. So over inside the component, add the state variables like so. So we have a name filter and a ID filter, which are initially initialized to 2 empty strings. Then we'll go ahead and create our use effect over here like so. And like I said, this use effect will only be triggered if the name filter or ID filter change within this component itself. The first thing we'll check in this use effect is if both of these filters are an empty string, we'll just set our filtered NFTs to the original NFTs array because we won't have any filtering. So over here we have this conditional. If our ID filter's length is equal to 0 and our name filter's length is equal to 0, then we know that the filters are empty strings and we can go ahead and set our filtered NFTs just to the NFTs itself. So go ahead and add that over here. Let's return and set our filtered NFTs to the NFTs array itself. Now, if this if statement is not caught, we have to initialize a empty array. And we can call it, for example, fill NFTs equals an empty array. And we'll start populating this filtered NFTs with NFTs from the original NFTs array that match the filter conditions. So for that, we'll have to have a few filtered conditions. So to start this off, we'll of course always have to loop through our NFTs array to check the conditions of the filters against every NFT in our array. Then within this for loop, we'll have our first conditional statement, which is if the NFT we're currently iterating over, name, includes the name filter that we've set, and the ID filter's length is equal to 0. So there's no ID filters, but there is a name filter, and it's included in the name of the NFT. We push this currently being iterated NFT into our temporary fill NFTs array. So this is our first case of filtering where we know that we don't have a ID filter, but we have a name filter. We check if that name is included in the name of our NFTs and we push them into our temporary array here. Now, next thing, we will do the exact same thing, but for the opposite. So like so. If our ID filter is included in the token ID and the name filter's length is 0, so there's no name filter, but there is a ID filter, we go ahead and push those NFTs into our temporary array. And then the final condition will be if there is both a name filter and a token ID filter. So in these scenarios, we just have to make sure that the NFT's token ID is included in our ID filter and the NFT's name is included in our name filter. If they're not pushed to our temporary fill NFTs array. But if they are pushed to our temporary fill NFTs array. And then finally, what we can do is just set our filtered NFTs to this temporary filtered NFT. So do that outside the loop over here. Under the loop, go ahead and use the set filtered NFTs hook to set our filtered NFTs to our temporary fill NFTs we created in this use effect. And that is all you have to do for the filtering part. Now we just have to make sure that we have an input where we set this name filter and ID filter. And then in our app, rather than rendering the NFTs array, we'll render the filtered NFTs. So let's do that first over here. So in our NFT processing array, we set our NFTs to T, but we can set our filtered NFTs to T as well. So go ahead and copy this and add a new array, set filtered NFTs. And we have to do this both because we're using the NFTs as a basis for filtering our NFTs. So that's why you have to set both of them in NFT processing. And in our return statement, rather than mapping through the NFTs, let's map through the filtered NFTs. Like so, filtered NFTs and filtered NFTs. So now what we're looking to do is next to our button, just add 2 inputs for our name filter and our ID filter, which is relatively easy to do. Let's give it a title of name filter and underneath and next to that, add that input where we on change, set the name filter to whatever is set in this text input, and the value of the input is always name filter. So this is how we can keep track of it. And then of course, underneath this input, we'll add another one for the token ID. Voila, this one we give a title of ID filter and the input is exactly the same. On change, we just set whatever is set in the text input field as the ID filter and the value will always be the ID filter. So now anytime this is changed or the name filter is changed, we will run our use effect, which has the name filter and ID filter as triggers, and we will get a new set of filtered NFTs, which we are in fact now rendering in our app as well. So everything should be good to go. You save this, jump into your React app, check this out. We have our name filter and we have our ID filter, and we can go ahead and fetch some NFTs for our wallet. Polygon network, fetch the NFTs, and look at this. We get all our NFTs. And now if we try and filter out for the lens NFTs, let's go ahead and type lens. I typed lems, so both of them went away, but lens, you have only these two NFTs. Less won't give you the right answer, but len will give you the right answer. And then you can add a ID filter. So say both of them has 65 in them, but this has 26. So let's add 26, and that just leaves this one NFT for us. Same thing, if we remove both of the filters and try and filter for rev, look at this, we only have these two NFTs show up now. So that is how you can simply add filtering in your React app for the NFTs in your portfolio. And that is the complete functionality of this app. You've done so much. You can fetch the balance of your native tokens, you can get your ERC20 tokens, you can get the total portfolio balance, you can get the transfer history for your user, and now you can also get your NFTs and even filter these NFTs out. Look at this. You've done so much. You should be very proud of yourself. This is your first Web3 app, but it still looks a bit unstyled, and Web3 is modern and new. We want to make our app look very pretty, so in the next section, we'll add some styling to this page to look cool and presentable. Let's get stuck into that. Rightio, final section of this course, we're going to style our React app that's currently looking something like this. So go over and head over to Google and search for Web3 UI Kit. The first result will be the Web3 UI Kit GitHub, and over here you see massive documentation, great documentation for how to use the Web3 UI Kit, and you even have this live storybook demo which have live examples of what the different components are, what the parameters they take, and so on and so forth. But for now, what we'll have to do is we're going to install it. So go ahead and copy this line over here, jump into Visual Studio Code, open up your terminal, and we won't be installing it in our backend file, but be sure to go into your front-end folder, press Ctrl+C, and paste the install in here so we get Web3 UI Kit installed in our project. After that's installed, you can restart your client-side app by running npm start, and it should just refresh your React app like so. Now jumping back into Visual Studio Code, we can close down our terminal and we'll go jump into the app.css file. So on the Academy side, there will be specified courses for front-end styling of your apps. So we won't get too in-depth of these CSS classes, but I'll add them over here and they'll be available for you in this final code repository where you can go check them out in more detail. We just have different classes for headers, titles, wallet inputs, and so on and so forth, which we'll use in some of our components here when we style our app. But the main focus will be the Web3 UI Kit. So we'll save that. And first of all, what we'll want to do is make a nice header. And if we check out our app.js, the first component we have in our whole app is the wallet inputs. So it makes sense just to have the wallet inputs component be our header. So you can jump into the components folder, jump into the wallet inputs folder, and first of all, let's go ahead and import the app.css file like so. And then let's import a couple of things we'll use from the Web3 UI Kit. So here we'll use a text input because we have that input where you can add your wallet, and then we'll use a select input where you can choose between Ethereum and Polygon, and then we'll use crypto logos because we'll have the logo of Ethereum and Polygon to present in that select input, and we're importing them from the Web3 UI Kit core. Right, so just to keep things simple, let's just delete everything we have rendering right now and add a simple div with class name equal to header. This is set in the app.css file. And at this point, you can even check it out. So save the file and jump into Google Chrome. And look at this, we have a dark header added to our React app over here. And one thing we'll do right now is let's go get the Zapper logo so we can put it over in the top left corner of our app. So jump into the Zapper webpage. All right, so here we're on the Zapper page. Let's inspect the page. It opens up our console and let's select an item. Let's select this. And we have a SVG over here, and let's just copy this SVG, copy element, and now we have the SVG we can use in our own React app. Like I said, this is just for demonstration purposes. So over here, let's first add this div called title so we can have a logo and some text next to it. And then within this div, you can paste that SVG and the title you want for the app. So in our case, we have the SVG here, and we just said set a title of H1 Zapper. Now saving this, let's go check out what it looks like. Beautiful, beautiful. Just one thing, our text is black. So because we're gonna have a dark theme, let's just go make sure that our app's background is dark and all the text is by default set to white. So jump into Visual Studio Code, jump into your index.css file and the body over here. We can set a dark background color and the color of the page to white. Save that, check out your React app. And look at this, things are looking way better now, and we have a cool title over here. Now over here in the right, we'll have the wallet input and chain selection, which are components from the Web3 UI kit. Let's do those next. All right, so jumping back into Visual Studio Code, in the wallet inputs component, outside of the title div, let's add a new div called wallet inputs, like so. And in here, we'll add our two inputs that we just brought in from Web3 UI kit. All right, so first for our wallet input, so it'll be an input and the ID will be wallet, label will be wallet address, label background color will be the same color as our app itself, and the value of the input will be the wallet as was before in our original just HTML input. And then we'll give it a height of 50 pixels, and on change it will set the wallet global state variable so that we can send the correct backend calls. And if you're wondering where you get all these parameters, you can always go ahead and check out the storyboard, check out the forms. So we have a input button over here on the Web3 UI kit, and you get all the different parameters that these inputs take. So I suggest you, when watching this video, if you're stuck at some point, go check out this documentation yourself so you learn better at what we're doing. So now jumping back into Visual Studio Code, you can save this and let's go check out what it looks like. That's beautiful. We have a beautiful wallet address over here where we can add our wallet. And now next to that, let's add our selection of chain. So jumping back into Visual Studio Code, let's add that select input next. All right, so this component is slightly longer, but it is very simple. You're just setting the default index to be the first element in our options array. And then on chains, you're setting the chain to whatever the value is in the option itself. And the option has an opportunity to put a prefix where we're adding our crypto logo, and the Web3 UI kit comes built in with the Ethereum logo and the Polygon logo, so we get them from there. Now saving that, if we go check out our app, look at that, it's beautiful. Our Ethereum and Polygon options are here right now, and our header is quite ready. What we can do is go ahead and change the default class of this component, but I'll add these in the index.css file for you straight away. So going into index.css, there'll be a few classes that we need to manually adjust to make them coherent with the styling of the page. So this is something you can get from the final repository as well. So there's only these two components where we're setting the style to be more coherent with the other styling of the page. So if you save that, you'll see that in our Google Chrome, our background color of this input has changed beautifully. How cool is that? So now, next things next, let's add some tabs for these different pages. So we'll have a tab for the tokens, we'll have a tab for our history page, and we'll have our own tab for our portfolio NFTs page. Let's do that next. Jump back into Visual Studio Code. You can go over and head to the app.js file, where we'll import a couple of things from the Web3 UI kit. We'll import an avatar, tab list, and tab. So tab and tab list is what we'll use now. Avatar is something that's coming a bit later. So we'll create a list of tabs, and then we'll have these separate components like the tokens, the transfer history, and the NFTs in their separate tabs. So to do that, in your app div, after the wallet inputs, which was set as the header, let's create a new div and give it a class name equal to content. And within this div, we'll create our tab list, which is super simple to do. Let's scroll down a little bit, add it over here. Tab list in which we have 3 tabs, and the tab names are tokens, transfers, and NFTs. So what we can do now is put our components within these tabs itself. So let's take our tokens components, cut these, and chuck them into the first tab, like so. Do the same thing for our next tab. So in this tab, transfers, we'll only have this one component called transfer history. Cut that and chuck that into the next tab. Voila, the transfer history is in there. And then in the final tab, we'll put our NFTs component. So copying that and putting it in here. Beautiful. That leaves our portfolio value component without a tab because that will be present on every page. So we'll just add that, Command X, and put it in above our tab list over here, and we'll style it nicely a bit later here. Beautiful, beautiful, beautiful. Now let's save this page and go see what we did. Well, would you look at that? How cool does that look? Now we have our portfolio total value over here, but we have our different tabs. So we have our transfers, NFTs, tokens. How cool is that? And it actually works right now. So if you fetch the balance, you get the balance, getting the tokens, gets the tokens, same for transfers, fetching transfers. You get all the details, same for NFTs, fetching the NFTs. It all works right now, but we want to make this a bit more stylish, add some tables so it pops out even better. And then we'll also add at the end this portfolio total value nicely and a little avatar with the wallet address. Let's go ahead and jump back into Visual Studio Code. And in here, let's start going through these components that are in our tab. So first of all, the native tokens. Let's jump into that component over here and import the two components we'll use from Web3 UI Kit, which is a table from Web3 UI Kit core and a reload icon, which we'll use to actually fetch the native balance and run the get native balance function. So then jumping down to the return statement, we can again remove everything we have so far. And to start off, we'll have a title and the icon to actually fetch the native balance. Beautiful, like so. So we have a div with a class name of tab heading. It says native balance, and next to that, it'll have a reload icon that on click gets the native balance. Then we'll conditionally render the native balance as long as the native balance and native value is over 0. And it's as simple as that. So we have our conditional statement over here, native balance and native value are over 0, and then we render a Web3 UI Kit table. The page size is 1 because there's only going to be one native balance. We won't need pagination because there'll only be that one row of data. And then we'll just give it some styling, the columns, and the width of the whole table. The data itself will be an array of arrays. So we'll only have that one row. So this first array in this whole array of data will have the data we'll display. So of course it'll be the native token, and first we'll have the native balance, and the last cell will be the native value, and the headers will be currency balance and value. That's as simple as it is. We save that. We can go check it out on Google Chrome. Look at that. How neat is that? So we have our currency balance value, and they're presented nicely over here to us. Now we'll do the exact same thing for our ERC20 tokens. So jumping back into Visual Studio Code, jump into the tokens component, bring in the same components in here. So the table and reload button. Then we can remove our current return statement. And because we're doing exactly the same thing, I'll just paste out the whole thing like so. So in this case, our table heading will be ERC20 tokens. We'll have the reload button, which will get the token balance, not the native balance. And as long as the tokens array's length is greater than 0, we'll render the table. And what we're doing for the data, we're mapping through the tokens. And from each token's data, we're getting the symbol, its balance, and the value we calculated in earlier sections of this video. The headers will be the same, currency balance and value. Save that and go check out your app. And look at this, we have our USDC and wrapped Ethereum balances, and they're triggered by this reload button. So if we refresh the page, set our wallet address, Polygon network, press the reload button, you get all the details. How sweet is that? Now let's jump into the transfers, where we'll add a table for this as well. Jumping into Visual Studio Code and the transfer history component, we're essentially running through the same process. We're bringing in from Web3 UI Kit the reload icon and the table component. Then in our return statement over here, we can delete everything we have so far, like so. Start off by initializing a header with the reload button, which triggers the get token transfers functionality. Boom shakalaka. So the transfer history is the name, and then we have the reload icon over here. And then under that, we'll have a div including the table of transfers. Now this is going to be slightly longer, but don't get worried. We'll talk through it. So as long as we have that global state variable for a transfers array and its length is over 0, we can go ahead and map that transfers array, and from every transfer get these headers: a token, amount, from, to, and date. So the token, of course, is the symbol. For the amount, we get the value divided by the decimals to 3 decimal points. Then the to address and from address, we slice the first 4 digits, then we put 3 dots, and then we slice the last 4 digits. So it's just in a bit more compact form. And then for the block timestamp, we get the first 10 digits, which will result in displaying just the year, month, and date of the transaction. And that's it. That's all you have to do. Save that, jump in to Google Chrome. Transfer histories over here. Let's fetch them. And boom, shakalaka. Look at this. USDC. That one wrapped Ethereum transaction, and all else are USDC transaction. Now, if you had more than 8 transactions, you'd have different pages for those transactions. And as you see here, the date, we have most of them happening on the 30th of August, but some of them happening on the 31st of August. Very, very cool. So now we have the tokens and transfers. We can move on to the NFTs. For the NFTs, we won't need a table, but we will need inputs like we had over here for the wallet address to have nice input fields for the name filter and ID filter. So jumping into Visual Studio Code, locate the NFT.js component, scroll up to the top and import the reload icon and the input component from Web3 UI Kit core. So now, finding ourselves way to the bottom, we can again remove everything we've already created in the return statement and create a new return statement. Starting off, we'll again have a tab heading div with NFT portfolio and the reload icon, where on click we handle the get user NFTs function. Then let's go ahead and create a div for our filters. So we'll have filters after our heading. So first a filter for the name. So we have the ID name F. The label will be name filter, and the value will be the name filter state variable we have in this component itself. And on change, we will set the name filter variable, which will in turn fire. If you remember our use effect over at the top here, use effect is fired when the name filter changes. We have to do the exact same thing for our ID filter. So essentially exactly the same, just handling the ID filter state variable. Save that. Let's go see that this looks good. So yeah, looks awesome so far. The filters are there and the NFT portfolio is up here. So now just rendering the NFTs. Let's jump back into Visual Studio Code and create a div called NFT list. Over in there, it looks beautiful. And in this, we'll have a conditional rendering. As long as we have our filtered NFTs, we'll display them nicely over here. Like so. So we have our NFT list div over here, and within it, we have a conditional if our filtered NFTs length array is over 0, we map through them, and we have a NFT info div in which we have the image of the NFT as long as we have the image. And then underneath that, we'll have the name and the ID sliced to the 5 first digits of the token ID. Just to render tokens with very long 10, 20 digit IDs nicely on the page. Saving that. Let's go see how it looks. So let's go ahead and fetch our NFTs. Looks like the NFTs are rendered in the inputs div. So let's go ahead and move them out. So our NFT list over here has to go outside the very last div over in here. Save that. That should be better. Now opening up Google Chrome, look at that. How pretty is that? And our filters should work perfectly. Lens over here, ID 26. Look at that. Instant feedback for your NFT portfolio and filtering it as you wish. That is basically it. We've completed all the tabs. It looks awesome, awesome, awesome. Now just making a little profile avatar over here and your total portfolio value on the top right, which you see when transversing between all the tabs. Then we're done. All right, so for the profile section, we'll have to ensure that we have 42 digits in the wallet to be able to display the wallet address. So let's make a conditional in our app.js file. Jump outside of your components folder into the app.js folder. And here at the very top, inside the content though, just above your portfolio value, let's make a conditional rendering of a div named wallet info. And as long as we have a wallet length that is equal to 42 digits, then we can display information in here. And because we already brought the avatar in from Web3 UI Kit, you could use whatever you want as well. You could use blockies or check if they have an ENS domain, but we'll just use the avatar image from Web3 UI Kit and display it in here. So we'll have an avatar, we'll use the isRounded property, we'll give it a size of 130, and underneath it, we'll have a heading where we again slice the first 6 digits of the wallet, add 3 dots, and slice the last 6 digits to clearly indicate whose portfolio we're looking into. And then we can take this portfolio value component over here and add it to this wallet info div just underneath our profile. So over here, like so. We might need to make some changes to the portfolio value component itself, but let's look at what this looks like so far. Look at that. We have a beautiful profile avatar picture. We have their wallet address. It's dependent on what wallet address we set over here. But then we can head over to the transfers, NFTs. And now last thing is to add that total portfolio value tag over in this top right corner to look nice. So jumping into Visual Studio Code, check out your components, portfolio value component, and this is a super simple adjustment. Just add the following in the return statement: a div with a class name of total value, a heading 3 with portfolio total value, and a heading 2 with the total value state variable. And to get this class, we of course need to import app.css. So importing app.css, save that. And now we should be ready to rock. Open up Google Chrome and look at that. Portfolio total value is $3.41. And we can even check this out. So going to tokens, we can change our wallet. Let's refresh the page, set a wallet over here on the Ethereum network, check for the native balance, So we have $6.33 worth of Ethereum, and how many ERC20 tokens? We have USDC tokens worth $6.64, and look at that, that equals $12.97. So now we know our portfolio total value is working. And now just returning back to the original user, let's check out every page. We got the tokens, we got the transfers, we got the NFTs. Everything is working awesome. You've built your first Web3 Dapp, and it's all done using the Moralis EVM API. I hope you really learned something from this course and can take some notes going forward in your Web3 development journey. Okay, that's it for me. Thank you, and see you in the next one.